So we're going to jump into a new chapter dealing mostly with sequences and series. A lot of this is Algebra 2 review, but we will probably take it up just a little bit of a level than what we were at before and add on to some things we had done in the past. So let's begin by quickly reviewing what a sequence is. It's basically just a list of numbers or variables with some kind of pattern. So you see below this sequence here of 2, 4, 6, 8. These are the values in the sequence. The first term being 2 is notated A subscript 1, in other words meaning the first term. So the second term, notated A subscript 2, is 4, and so on and so on and so on until we get to this last term, which we typically call the nth term, notated A sub n. And we have what's called an explicit formula. And what that does is it gives us a formula in which if we want to find any specific term in the sequence, all we have to do is take the subscript of that term, plug it in, and that will be the number. So for instance, if I want the fifth term, A sub 5, the subscript number is 5, and if I plug a 5 into n, I get an output of 10, and that would be the fifth term in that sequence. So A sub n in this case, equaling 2n, is that explicit formula that we're talking about. Now today what we're going to deal primarily with is arithmetic sequences. All right, an arithmetic sequence is a sequence in which a common difference exists between terms. So if we look at this first example, we notice that from the second term to the first term, if I have negative 1 minus 10, that's equal to negative 11. And from negative 12, we always go backwards. From negative 12 to negative 1, we get a difference of negative 11. Thus, the common difference, or D, is equal to negative 11. And that continues throughout the sequence. In this next example, we have variable expressions. So there must be a common difference between the first variable expression and the second. So I take x minus 1, and I subtract from that x minus 4. Notice the x's will go away, and I end up with 3 as my difference here. But it has to be consistent with the next difference. So let's again take x plus 2, subtract from that the quantity of x minus 1. Notice again the x's will go, and minus a minus 1 is plus, and I get 3. So the difference in this case is actually equal to a constant value of 3. Now once again, here's another variable expression. From x plus 1 to 3x minus 1, I get negative 2x, and minus a minus is a plus, plus 2 as my difference here. Let's try it again from the third term to the second term. I get 3 minus x, and I'm subtracting x plus 1 from that. You'll notice negative x minus x is negative 2x, and 3 minus 1 is 2. So the common difference in this case is an expression of negative 2x plus 2. So now what we're going to do is we're going to go about writing an explicit formula for this sequence of 5, 8, 11, 14. And we're going to do that by taking a look at how we get from one term to another by using the common difference. So in this case, we have the first term plus no common difference. So it's just the first term, blank. The next term is the first term plus a common difference of 3. And there's one common difference there. Now, to get from 8 to 11, I use the first term, and then I add another difference of 3, so I'm at 2 differences of 3. To get to the next term, 14, I use the first term, and I add another common difference of 3, thus 3 common differences. Now what we want to do is we want to generalize how I get to the next term. All right. In this case, I'm going to use the first term plus how many common differences? Now, this could be 10, 11, 12, 13, 14, whatever I want it to be. In order to figure this out, what we want to do is we want to look at the subscripts here, here, and here. So when I'm on the second term, I'm using 1 common difference. Third term, I'm using 2 common differences. Fourth term, 3 common differences, etc., etc., etc. So what's the relationship between the subscript and the common difference? Well, we can see they all differ by 1, the common difference being 1 lower than the subscript. So I can state then, in general, that if I take the first term, multiply it or add it to the common difference times the number of the subscript, which is n, minus 1, then I will get my next term in line. So, writing that all out, the general explicit formula for arithmetic sequences is the nth term is equal to the first term plus the common difference times the numbered term minus 1. So once again, a sub n is the nth term value, a sub 1 is the first term, d is the common difference, and n is the number of the nth term. In other words, the subscript. Value. Be important to memorize this formula. So what we want to do is we want to write an explicit formula for this sequence here. Well, in order to do that, I need an expression for a sub n. That's going to be given by the first term, I'll just write the formula again, plus the common difference times n minus 1. And in this case, we know the first term is negative 13. I can look at the common difference, and that ends up being a positive 4 because that sequence is increasing. And we don't know how many terms we're going to have, so we leave the n in the explicit formula. We have to have something to plug into. So I can generate any term in this sequence by saying negative 13 plus 4 times n minus 1. I can do a little bit of math on that and say this is negative 13 plus 4n minus 4, or negative 17 plus 4n will generate any term in this sequence. And to verify that, let's say I want the third term. Well, the third term, a sub 3, is found by taking negative 17 and multiplying it by 4 times the subscript. That ends up equaling negative 5. Sure enough, negative 5 is my third term. So once again, my explicit formula is a sub n is equal to negative 17 plus 4n. Now if you wanted to, it would be okay to leave it in this form as well, since that's kind of the nature of the equation. However, simplifying it, we look like this. Now I want to find the 41st term in an arithmetic sequence. I know this is arithmetic because I have a common difference here of -7. So if I want the 41st term, I'm looking for a sub 41. Notice I have a subscript value of 41. So to find any term, I need to take the first term plus the common difference and multiply that by the subscript value, which is 41, minus n, or minus 1, I'm sorry. So we end up with, in this case, 11 plus -7 times 40. So that's going to be -280 plus 11 is -269. And that is the 41st term. Let's head over to the next problem. I want to find the first term of a sequence given that a common difference is 8 and the 47th term is 229. So I know, once again, I'll write it up here, a sub n is equal to the first term plus the difference times the subscript minus 1. All right. Now I'm looking for the first term, so that's my unknown in this case. I have a common difference of 8, and I have a subscript value, 47. Minus 1 gets me the value of the 47th term. Remember, a sub n, this is a value. So that's 229. Now I just grind this out. I have 229. It's equal to the first term plus 8 times 46. And 8 times 46 is 368. So therefore the first term is roughly 139 of the negative type. Let's move to that next example. So here we have a new definition where the terms between any two non-consecutive terms are called the means of a sequence. So here are my non-consecutive terms, one of which being -17 and the other being positive 199. And I'm going to find the 6 terms in between these two terms. Now, what I do know is that 17 is the first term of this sequence, and 199 is the 8th term in this sequence. So all I really need to do is find the value of D and add that all the way up. So I have 199 equaling -17 plus whatever my D value is times 8 minus 1. So adding 17 to 199, I get 216. And that's equal to 7 times D. So D equals 216 over 7. And if I add that to -17, what, 6 times, 7 times, I get -199. So we do that, we get -17 here, and continue to add all the way up. So the first time I'm going to give you some approximations is about 13.85. Second time, 44.71. Third time, 75.75. Next time, 106.42. Next time, 137.28. followed by 168.14, and finally that gets us to 199. And there's my 1, 2, 3, 4, 5, 6 means between the two non-consecutive terms. I want to find the 23rd term in this next sequence. Now I'm going to show you a couple of different ways to do this. The first way is going to be using a system of equations. So we know that the 23rd term, or a subscript 23, is equal to 19, and a subscript 31 is equal to 43. Now if I use my general equation, I know my 23rd term, 19, is equal to my first term, which I don't know, plus my common difference, I also don't know that, times the subscript, which in this case is 23, minus 1. I also know that I have 43 being my 31st term. That's equal to my first term plus the common difference times its subscript, which is 31, minus 1. Now notice, this is 19 equals the first term plus 22d, and this is 43 is equal to the first term plus 30d. I have two equations, two unknowns, and I should be able to take and solve this system. So I'm going to write this first equation underneath, and I'm going to take and subtract. So I take 43 minus 19, and I get 24. The A1s go away, is equal to 8d. Therefore, the common difference is 3. If I know the common difference is 3, I can find my first term by plugging it into either one of the two equations, which I'll do. I know that 19 equals the first term plus 22 times that common difference of 3. So I'm going to take 19 and subtract 66 from that. It's going to get me negative 47 for my first term. Now, that's one way to get the problem done. And it's kind of plug and chug. Now I'm going to do this a little bit more creatively. And what I'm going to do is I know that no matter what, from term to term, my difference is still the same. So what I'm going to do is I'm going to say, well, I know the 23rd term is equal to 19. And I know the 31st term is equal to 43. What if I were to slide all these down so that this were the first term and this were some other term? The common difference between each is the same. So let's say a sub 23 becomes the first term, and that's going to be 19. It's not the first term, but let's just say it was. So moving from the 23rd term to the 21st term is a difference of 22. So I'm going to say then the 31st term, if I move that 22 down, this puts me at the 9th term. So now I have a first term and a 9th term. I should be able to find the common difference relatively easily. So I say, well, 43 is equal to the first term, which is 19, plus the common difference, which I don't know. But now I have this new subscript for 43 of 9 minus 1. I take 43, subtract 19, once again, get 24. That's going to equal to 8d. Therefore, d is equal to 3. Got the same difference as I did in the last problem. But now in this case, if I have a common difference of 3, I'm going to now, in order to find that first term, use my 23rd term and this common difference to find the first term. So part 2 is say, all right, well, my 23rd term is 19. I'm looking for my new first term. So I'm putting everything back in its original spot, plus the common difference we found was 3. Now the subscript of this 19, the original subscript, is 23 minus 1. So 19 is equal to the first term plus 3 times 22, or 66. If I take 19, subtract off 66, I end up with negative 47 for my first term. And if you look back at the last example, there's negative 47 as my first term. You can do it either way you like. Doesn't bother me. Just figure out a way that suits you. So here are the questions for the day. Get them answered on the forum, and I'll see you tomorrow.